In this video, I will be simplifying radicals. I will be simplifying the three radicals that you see on the screen, number 51, number 63, and number 89. These are from your text on page 576. Okay, so first I will simplify each expression using the rules of exponents, and I'm going to explain the steps that I'm taking. And then as soon as I'm done with that, I'm going to write each expression in the equivalent radical form and then demonstrate how it can be simplified in that form if it's possible. Okay, so let's start with number 51. So I'm going to simplify this expression using the rules of exponents. Okay, so let me rewrite the problem so we know which one we're looking at here. We have 2 to the negative 4, and it's raised to the 1/2 power. Okay, so this exponent, all right, working on an exponent calls for the power rule. So what we're going to do is we're going to take 2, and then we're going to take the exponents and we're going to multiply them. So we have minus 4 times 1/2. Okay, so the base stays the same. So minus 4 times 1/2 is minus 4 over 2. And so this becomes minus 2. So now we have 2 to the minus second power. All right. So this negative exponent, what we need to do is we need to make a reciprocal, all right, of the base number and the exponent. So let's go ahead and do that. So that becomes 1/2 to the second power, right? So the denominator becomes 2 to the second power. Okay, so what we did was we got our reciprocal and then we made the exponent positive. All right, so what is 2 to the second power? Well, that's 4, right? Because 2 times 2 is 4. Right? The exponent tells us how many times the base is repeated. All right, so that's our answer. Okay, so now let's redo this same problem, except what we're going to do is we're going to write this expression in the equivalent radical form, okay, and then simplify it. So I'm going to erase this here and then start over, and we're going to do it in the radical form. So let me rewrite this expression so it's clear, because I couldn't get the exponents to come through up here. So we'll rewrite it. So we have 2 to the minus 4th power, and then that is raised to the 1/2 power. Alright, so in radical form, so what we're going to do then is we're going to change 2 to the negative 4th becomes 1 over 2, and then the exponent becomes positive, right? This stays the same. Okay, well, what's 2 to the 4th power, right? That's 16, because 2 times 2 times 2 times 2 is 16. Okay, so we have 1/16 raised to the 1/2. Okay, so when we have a rational exponent, we're going to put that rational exponent on each of the elements here. Okay. And so then what happens is the 1, right, we're going to do its equivalent in radical form. It's going to be the square root of 1, right? This is really 2, which is we don't usually write. Okay, and then that goes over the square root of 16. And again, we don't have to write the 2, but I'm going to write it just so that you can see what's happening. All right, well, the square root of 1 is 1, and the square root of 16 is 4. Okay, so we got the same answer. So it's up to you to decide, well, which way is easier for you. Okay, personally, I thought simplifying the expression using the rules of exponents was a whole lot easier to deal with than this here. All right, so let's work on our next one. Okay, so for number 63, the first thing we're going to do is we're going to simplify the expression using the rules of exponents. Okay, so 63 is 81 x to the 12th over y to the 20th, and that is all raised to the 1/4 power. Okay, so as we see, we have to raise each of the factors to that 1/4 power. So when we're looking at number 81, okay, it's going to be easier if 81 was in exponential form. So we have a choice. We can either convert it to to a second power or to a fourth power, okay? And so just think about this for a little bit, okay? So what's the square root of 81, right? Remember, that's the square root of 81. Well, that's 9, right? So which is 9 to the second power, okay? So we can't do a cube root, but we can do a fourth root, okay? So the fourth root of 81 equals 3, right? So 3 to the fourth power equals 81, okay? Well, if you notice, it'll be easier to deal with 81 if it's 3 to the fourth power because our denominator is 4. Remember, we're going to be multiplying this power or this exponent against this exponent on the inside of the parentheses, okay? So this is going to be an easier term to deal with. So let's go ahead and convert that. So 81 becomes 3 to the fourth power. Okay, so I'm going to rewrite this so it's clear. I mean, it's equivalent, okay? We're just putting it in a form that's going to be easier to deal with because it's going to help us get rid of our rational exponent, all right? All right, so let's go ahead then and raise each of these factors to the quarter power, okay? So this is going to be 3 to the quarter power times a quarter up here, and then we're going to have x to the 12th times a quarter. That's going to be over y to the 20th times a quarter. Okay? All right. So 3 to the fourth power times 1/4 power. Okay, so we're going to multiply the exponent. So 4 times 1 is 4 over 4. Right? And I hope you see where this is going. And then x is 12 times 1 over 4. Right? So it's 12 over 4. We'll simplify these in just a minute. I'm just trying to go through every single step. 20 times 1/4, right? So that's 20 over 4. Remember your multiplication for fractions, okay? Multiply across the top and then across the bottom. All right, so 3 to the 4 over 4th power, right? That is 3 to the first power, okay? So just 3. Okay, so then 3 and then x, and then 12 divided by 4 is 3. And that's going to go over 20 divided by 4 is 5, okay? So we have 3x to the third power over y to the 5th power. Okay, so this is as simplified as we can get. So this was number 63. It's 81x to the 12th over y to the 20th, all raised to 1/4 power. And this was using the rules of exponents, okay? So now what we're going to do is we're going to write each expression in the equivalent radical form, okay? So let's go ahead and do that. Okay, so the first thing we need to do, raise each factor to the power. All right, so here we go. 81 to the 1/4 power, x to the 12 to the 1 times the 1/4 power, over y to the 20th, and this is going to be times the 1/4 power. Okay, so 81 to the 1/4 power, okay, that in radical form is going to be 81 to the 4th root. Okay, and then x is going to be 12 over 4, which simplifies to 3. And this goes over y, and this is 20 divided by 4, which is 5. Okay. Okay, so in this case, we're going to pull perfect fourth roots out from under this radical, right? So in this case, we're going to remove the 3 because it's the perfect fourth root. Okay, so this becomes 3x to the third over y to the 5th. Okay, so we have one more problem to work through, number 89. And this problem is minus 8 over 27, all raised to the 2/3 power. All right, so first we're going to simplify this expression using the rules of exponents. Okay, again, we're going to use the power rule. Okay, so on all of these problems so far, we've been using the power rule to multiply the inner exponents. Okay, so let's go ahead and do that. We notice, again, it will be easier if 8 is in exponential form, and if 27 is also in exponential form, all right? So we can eventually eliminate the rationals, all right? So let's go ahead and just convert each of these numbers to an exponent. All right, so we can convert 8 to, let's see here, 2 to the third power, okay? That'll help because our denominator here is 3, so that's going to get rid of that rational expression really nicely. All right, and so we can actually do the same thing for 27. So 3 to the third power is 27. So we can certainly convert this to an equivalent form using exponents, okay? So we'll raise that all to the 2/3 power. Okay, so now let's go ahead and use the power rule to multiply the inner exponents, okay? All right, so this becomes minus 2, right, to the third power, and that's going to be times 2/3, and it's going to be over 3 to the third power, and that's going to be times 2/3. Okay, so on the top here we've got minus 2, all right, and so then 3 times 2 is 6 over 3, and then on the bottom we have 3 times 2 is 6 over 3, okay? All right, so this is going to be 6 divided by 3 is 2, and then 6 divided by 3 is 2, okay? And then minus 2 times minus 2 is going to be a positive 4, and then 3 times 3 is 9. All right, so our answer is 4/9. All right, so now let's redo this expression in the equivalent radical form. All right, let me rewrite the expression so it's clear what we're working on here. Raised to the 2/3. Okay, so in radical form, this is what we're going to do. This becomes 8 to the 2/3 over 27 to the 2/3, okay? And then we're going to convert minus 8 to the 2/3 power to a radical, to its radical form, right? And this is going to be a cubed, and this is going to be squared, and then this is going to be 27 cubed, also to the second power. Okay? So this becomes, so what is the cubed root of minus 8? Okay, well we know that that's going to be minus 2. Okay, and it's going to be to the second power still. And then the cubed root of 27, okay, is 3, and that's going to be to the second power. Okay, so minus 2 times minus 2 is 4. 3 times 3 is 9. Okay, so our answer again is 4/9, and then I'll leave that up to you to decide which form is easier for you to simplify. Okay, well that concludes this video.